Okay, so good evening. We're going to start off with a review of the worksheet for conjectures and compound statements, which also goes into truth tables. Got hiccups, so I will try not to be hiccuping through this, but we'll see how that goes. So, when we're talking about compound statements, we're talking about the or, the and. So what we want to do here is we're going to start off with, it's Cleo, with identifying the truth value of our four statements. So we know that P is false because A, E, or C, E, and B are not collinear. It's these three right here. And if P is false, then that means not P is true. Remember that when we're dealing with logic, things are either always true or false. So if something is false, then the opposite of that must be true, and vice versa. The next one, we have Q is true. Their vertical angles, A, C, and D, E, B. Therefore, they're congruent, which means that not Q is false. EF is the angle bisector of angle AED, true, which means that not R is false. BEC is an acute angle. No, it isn't. And so therefore not S is true. Okay, so now when we get down to the next part, so this would be, number one would be P or Q. So number two would be Q and S. So I'm going to kind of shortcut these. I'd expect you guys to actually write out the whole thing, though. So points are collinear. So points C, E, and B are collinear, or A, C is congruent to D, E, B. So because it's an or, only one of these needs to be true. Now we know that P is false, but Q is true. And because we have an or, one of them is true, therefore we can say the whole thing is true. Now for Q and S, it's a little bit different. Q, AEC, is congruent to DEB, and because it's got the pointing up arrow, BEC is a Q. Now, AEC is congruent to DEB. That's true. We already figured that out. S is false. Now, because this is and, both of them have to be true for the compound statement to be true. Here, one of them is false. Therefore, the entire statement must be false. So if we look at number, looks like 4, 5, 6, 7. So not R or not S. So EF is not the bisector, or that angle isn't acute. Now again, that's why at the beginning we wrote out what P, Q, R, and S were, and then we also wrote down what not P, not Q, not R, and not S were. So in this case, we know that not R is false because R is true. It was the bisector, so therefore saying it's not the bisector is false. And S was false, which means that not S is going to be true. Here we have an or again, so therefore it's true. Okay, truth tables. So when we have these basic 2 ones, we put in both of our statements, P and R, and because each one can either be true or false, that's 2 options for each one. That gives us a total of 4 options, 2 by 2. 2 times 2. So what we do is we set it up like this. We set P up as true, true, false, false. And then we can't do the same thing for R because, or even flip it upside down, because that won't give us all the possible options. So if P is true, R can be true or false. If P is false, R can be true or false. So that gives us all four combinations: true, false, or true, true, false, true, false, false. So what we're being asked to determine are the possible variations of P and R. Okay? So for P and R to be true, we need both of them to be true. In this case, that only happens once. And then the rest would be false. Now, if we had Q and S, or S, notice it points down, so it's an or. We set up the same true, true, false, false, true, false. So Q or S is when either one of them is true. Well, here we have the exact opposite. On number 10, only 1 out of 4 is both true. Here, at least one of them is true, and 3 out of 4 times. And only 1 out of 4 is false. So we did this one in class, but we'll go over it again. This is P or not R, and that's in parentheses, so that's one statement, and not Q. So what we do here is we start off with P, Q, and R, and then notice that we have 2 negations in our statement. We have not R and not Q. So we'll write those down. So what the first thing we have to do is list out all the possibilities of P, R, and Q. So notice now that we have 8 possibilities instead of 4. It's because we just added another variable. So now, because Q, before we just had 2, so let's say P and R. So before we just had 2. So P and R, there were only 4 possibilities. Now, for each one of those 4 possibilities, we're adding in another 2 possibilities. For each one of the 4 that we used to have, Q can now either add another true onto it or another false onto it. So that gives us 8, 4 times 2. And so this is how we set it up. So now instead of going true, true, false, false, we still keep that half and half set up though. So we're going to go true, true. I forgot to put the rest of those down. True, 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 false, 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 false. And then we have R and P left over. So we do what we did last time when we had 2. True, true, false, false. True, true, false, false. And then Q, we're just going to go alternating. True, false, true, false, true, false, true, false. Now, not R is just going to be the opposite of what R is. So if R is true, not R is false. If R is false, not R is true. Same thing with Q. So Q goes, if we look over here, true goes, Q goes true, false, true, false, true, false, true, false, true, false. So not Q is going to go false, true, false, true, false, true, false, true. Gave it all away. Okay. So now notice that we have 2 of our compound statements. And that's because what we're ultimately trying to measure is the truth value of the statement P or not R as one part of it and not Q. So in order to compare P or not R with and Q, we first need to figure out the truth possibilities of P or not R. So because this is an or, only one of them have to be true. So we know that the first 4 are automatically going to be true because P is true in the first 4. Now, even though P is false in the first and the last 4, R, or rather not R, goes, during those 4, goes false, false, true, true. So those bottom 2 are also going to be true. So the only time we have 2 falses are on those 2 right there. So now we compare that column we just made to not Q. And we go, when are not Q and P or not R, so these two right here, when are they both true? They're both true 3 times, and the other 5, one of them is false. And that's it for that assignment.